So the first term, first coefficient we have is kc0. kc0 എന്ന് പറയുന്ന 1 ആണ്. Now that can be written equal to k plus 1 c0. ഇനി രണ്ടാമത്തെ കോഎഫിഷ്യന്റ് വരുന്ന ഇതാണ് kc0 plus kc1, that is k plus 1 c1. അടുത്തത് kc1 plus kc2, അത് k plus 1 c3 ആവും. പിന്നെ നമ്മൾ എടുത്തു പോകുമ്പോൾ k plus 1 c3 വരും, k plus 1 c4 വരും. And let us look at the last term. Last term varna y raised to k plus 1 inde. Okay, here you have kck minus 1. Okay. Then you have kck minus 1, that will be k plus 1 ck, and the last coefficient is kck. kck എന്ന് പറയുന്നതും 1 ആണ്. That will be equal to k plus 1 ck plus 1. So we now get all the coefficients in terms of k plus 1 cr form നമുക്ക് വരും. So that is k plus 1 c0 x raised to k plus 1 ആയിരിക്കും first term, plus k plus 1 c1 x raised to k y, then k plus 1 c2 x raised to k minus 1 y square, plus etc. So you will get k plus 1 c k. So that will be x y raised to k varum, plus k plus 1 c k plus 1 y raised to k plus 1. So this is going to be the expansion of x plus y whole raised to k plus 1. So that is summation r equal to 0 to k plus 1 c r x raised to k plus 1 minus r y raised to r. So this is going to be the expansion of x plus y whole raised to k plus 1. Hence, by mathematical induction, hence the result is true for r equal to n equal to k plus 1. So therefore, by mathematical induction, the result is true for all n greater than or equal to 0. So that is the proof for the binomial theorem. Now let us, so this was the first proof. So let us look at the second proof for the theorem. So the second proof is a combinatorial. So in the second proof, so what we are going to prove that is the coefficient of x raised to n minus r in the and y raised to r that is equal to NCR. So once this is proved, then we are done with the proof. So it is enough to show that the coefficient of x raised to n minus r, y raised to r in the expansion of x plus y whole raised to n is NCR. Now if you look at x plus y whole raised to n, that will be x plus y into x plus y etc. Into x plus y, so which is multiplied n times. Okay. Now, if I want to form the term x raised to n minus r y raised to r. But now multiply cheyumbo, I need to take n minus r factors. Appo oro factor num njan onnengil x choose cheyanam allengil y choose cheyanam. Appam x raised to n minus r into y raised to r kittanengil n minus r times I have to choose x from these total n factors. Adupole y njan r times choose cheyanam out of the n factors, out of the remaining factors. Appo ആദ്യം n minus r factors out of n choose ചെയ്യണം. അതിന് ഞാൻ അപ്പം ഞാൻ x plus y എടുക്കുമ്പോൾ x plus y എന്ന് എനിക്ക് x എടുത്താൽ മതി. I will not choose y in that case. Then അങ്ങനെ x n minus r times choose ചെയ്യണം. And now from the remaining I will be choosing y. Okay, so we choose either x or y from each factor, x plus y, and then multiply them together. So that's how we obtain the coefficient of x raised to n minus r, y raised to r. Thus, to form a term x raised to n minus r, y raised to r, we first select r of n factors, x plus y, and pick y from the r factors chosen. So, ആദ്യം y raised to r ആണ് നമ്മൾ സെലക്ട് ചെയ്യുന്നത്. So, for that we will select r of the n factors, and അതിന്ന് you have to pick y from that. And we need to pick x from the remaining n minus r factors. Now, let us look at the number of ways in which you can do the first step. First step in the we need to select r out of n factors, so x plus y. So the first step can be done in, so number of ways of choosing r objects out of n, that will be NCR. So the first step can be done in NCR ways, and now നമ്മൾ r choose ചെയ്ത് കഴിഞ്ഞാൽ ബാക്കി definitely there will be NC n minus r. അപ്പോൾ ആ n minus r എന്നെല്ലാം നമ്മൾ x pick ചെയ്യണം. So that can be done only in single way. And the second step can be done in one way. So thus the number of ways to form the term x raised to n minus r, y raised to r is NCR. So this completes the proof. So hence the proof. So this is the combinatorial proof for the binomial theorem. So the next problem is to show that for all integers n greater than or equal to 0, summation r equal to 0 to n, NCR is equal to 2 raised to n. So here again you have two proofs. So the first proof is, so for that we will use the identity x plus y whole raised to n. So that is summation r equal to 0 to n, NCR x raised to n minus r, y raised to r. So we put x equal to y equal to 1. So that gives 2 raised to n is equal to summation r equal to 0 to n NCR. So x 1 raised to n minus r varum, 1 raised to r varum. So both are equal to 1. So you're going to get 2 raised to n equal to, so this will be NC0 plus NC1 plus NC2 plus etc. NCN. Now let us look at the second proof. Now second proof, we will look at in terms of the power set of a given set of n elements. So let capital X be an n element set and let P of X be its power set. Now the power set will contain all the subsets of X. So let us count the number of elements in the power set. Count the number of elements in the power set. So in P of X, then cardinality of P of X will be, so we need to find cardinality of P of X. Now the set power set of X contains n elements. Now when you form the subsets, there can be subsets with no elements, then there can be one element, two elements and containing all the elements. Now for each r equal to 0, 1, 2, etc. n, the number of r element subsets of X is given by, now if you want to form an r element subset, that means you must choose r objects at a time out of the n objects. So that can be done in NCR ways. So those are the different selections. NCR number define that is the number of R subsets of X. Agane combination define because the ordering does not matter. So it is like finding the number of subsets. So the number of R element subsets of n elements is given by NCR. So therefore cardinality of P of X will be equal to, so first you will have set containing 0 elements, which is given by NC0. Then you have sets containing 1 element, that is NC1. Then the number of subsets with 2 elements. Then you will have the R subsets plus etc. plus NCN. Now you know that for any n element set, the cardinality of power set of X, cardinality of power set of X is 2 raised to n. So this result is known to us. So therefore NC0 plus NC1 plus etc. NCN is equal to 2 raised to n. So that is the combinatorial proof for this identity.